All right, student. One more time. Today gonna be our second note of the week. This note, okay. So this note will be on biogeochemical cycle. This is technically a review because we did mention this last semester when we talked about carbon cycle and stuff. So hopefully you still remember what we learned last semester. So same thing. Open your canvas. Open the note with Cami. So again, this is I believe this is our fifth note for the month. Don't forget we're gonna have our notebook interactive notebook check. So make sure you go back to and double check your canvas. So get all those notes ready. All right. So again, today what we are talking about. Let me turn on this. Okay. We're talking about biogeochemical cycle. Okay. All right. So what biogeochemical cycle, another name for it is what we call the nutrient cycle. Why? Because they involve the cycling of nutrients, things that organisms need to survive. Okay. So again, another name is biogeochemical cycle. And if you look at your vocab list, so don't forget to have your vocab list out. There's a word biogeochemical cycle. Bio stands for life, geo means earth, chemical is a reaction. So when you have earth or the non-living thing and living thing, remember what do we call when we have non-living plus living together? It's what we call the environment, right? So biogeochemical cycle. So this would be an example of biogeochemical cycle here, right? You have solar energy, right? Going in to a primary producer, autotroph, like grass. And then you have an herbivore, primary consumer, and then carnivore, decomposer, and so on, like a cycle, right? Things cycle around and so on. And you have nutrients, right? So decomposer, keep in mind, the decomposer are endothritivore, right? They are the one that break down all these dead stuff and bring the nutrient back. And the nutrients will cycle back to the producer, and then that repeat a cycle. Okay. Just a quick review. Since we talked about nutrients, last semester we did talk about macromolecule. Remember we said that living things require a lot of macromolecule, and there are 4 macromolecules that are the big deal in a lot of living things, including ourselves. They are carbohydrate, remember carb, lipids, protein, and nucleic acid, right? You gotta remember carbohydrate are function, the job is to give us immediate energy. That's why we eat a lot of carb in the morning, pancake, flours, bread, right? Things that are high carb. So that give us the immediate energy to survive the whole day, to work. And then whatever extra energy that we don't burn off, you gotta remember the 10% rule, right? You eat 100%, throughout the day, you're gonna burn off 90% of those energy. So you keep only 10%. But if we don't function normal, we don't go out and work or be active, then we might keep more than 10%. And that 10 extra will become what we call lipids, right? Fat. And then we also talk about protein, remember? Function for protein is for growth, right? And you gotta remember we talk about DNA, transcribe into mRNA, mRNA then translate to a protein. Remember, protein is for growth. You have protein everywhere, right? You have protein for your skin, hair, for your dimple, right? For color of your skin, color of your eye. Those are controlled by protein. It gives us traits. Remember, genetic. So again, we are bringing everything back to now, right? All the thing we learned. And then of course we have nucleic acid, which are DNA, RNA, right? We learned about those. All of them have in common because they are considered organic. They're organic because they contain carbon, right? We might have heard people say organic food, this and that. Well, in biology, technically organic just means carbon. Anything contain carbon is considered organic or life, right? So speaking of carbon, so carbon is very important, right? Because carbon are cycles, a cycle to make these macromolecule, which we need and other organisms need. So how do carbon cycle in our environment? they go through what we call the carbon-oxygen cycle. Okay, carbon and oxygen, they also interact together, right? At some point. So we're looking at this picture, just a quick review, right? We have carbon connect to oxygen, CO2, carbon dioxide. Remember photosynthesis, plant use it, make food for itself so it can grow. It also requires sunlight. And then the animal will then eat the plant, right? So then that carbon are being passed to the animal and the oxygen. And then the animal will release, plant release oxygen now, right? Remember oxygen, okay? And then the animal will then take in the oxygen, remember? Cell respiration, and eat the food. Oop, my bad. It's supposed to be this way, right? So this way. Energy being passed to, remember? Energy passed. Okay. Right. And then when the animal die, it might be buried down, it become fossil or fossil fuel, right? Dead plant, dead animal become crude oil. And then that crude oil will then be used for factory, and then factory will burn it and will release back carbon dioxide. So carbon being traveled around, right? And a lot of time it stick with oxygen as well. Okay. And today we're going to talk about two biogeochemical cycle that are very important. Okay. And the first thing is we're going to focus on carbon and oxygen. And again, little review on carbon, right? You learned this last semester too, and also physical science. Carbon is an element, right? It has very stable because it has 4 open bonding, right here. It has 4 bonds. So it has 1, 2, 3, 4 valent electrons. So it can bond, it create like a stable, a strong bonding. That's why it's made in diamond, for example, right? It's the basic of life on Earth, right? We need carbon for a lot of things. And remember, we said carbon cycle within living and non-living, or the environment, right? It passed through 4 spheres. You remember we learned about this too? 4 spheres of the planet. You have the air, the water, the life, and the land. But then, of course, they have their own name, right? We don't just call air, water, life, and land, right? Carbon can pass through what we call the atmosphere. This is the layer of air, right, surrounding the planet, atmosphere, in form of carbon dioxide. It can be in hydrosphere or river, lake, steam ocean, right, in the fish or plant, water plant. Or it can be in the biosphere, all living thing, right? Oh, my bad. Hydrosphere would be like you have volcanic vent under the ocean and stuff like that. And then it can be through light, biosphere, or lithosphere, rocks, right? So carbon cycle through these 4 different spheres. We learn about this, right? Air, water, living things, and earth or rocks. Okay. So that will bring us back to this carbon cycle, right? You get a chance, take a look at it again. Carbon cycle, it connect with oxygen as well as carbon dioxide. Right? Photosynthesis, sunlight, carbon go in, carbon dioxide, animal eat it, plant release. What is it release? Oxygen, right? That energy then go to the cow. The cow will then release back carbon dioxide, right? And then the cow die or being eaten by another animal. It will decompose. It become fossil fuel, fossil. And the energy are then bring back to the factory. It burn off. It bring back carbon dioxide to create a cycle, right? And that is the carbon cycle. Remember during the 11-hour video, we also talked about, remember like before the Industrial Revolution, human population are low. And that's because we primarily just use the energy from the sun, right? So there's just enough resources. So that way human population stay close. Because remember we talked about population grow depending on the limiting factor, the resources. If you have more, then more growth, okay? What do you call the growth that keep going like a J? exponential growth. But it get to a point where it will slow down and stop growing, logistic growth. But then remember, humans start discovering fossil fuel. And that is from dead animal and plant that got buried over year. We dig it up, we convert them into gasoline, oil, we burn them off, we bring back more carbon dioxide, a lot more carbon dioxide. Does this sound familiar? And when you burn up a lot of carbon dioxide in the air, more than what the plant can recycle, that lead to what we call global climate change, and that we'll add more later. Okay, so again, carbon cycle, when you get a chance, please take a look at it, right? It involves photosynthesis, remember, plant, and respiration, animal. Opposite, but similar, but opposite, right? When you get a chance, again, read this, what I just said. Human impact, right? We talk about when dead animal and plant die, they become fossil fuel. They get buried over and they don't decompose. Over time, we dig them up, fossil fuel, and we burn them. When we burn them, we release more carbon dioxide to the atmosphere, increase global climate change. So keep that in mind, okay? And also having fewer plant, less forest does not help, right? Because plant recycle carbon dioxide, but we have less and less. So that increase our global climate change problem, right? So this is another picture to show you carbon cycle. So beside carbon and oxygen technically, but mainly carbon, we also have another nutrient that's very important to all living things because they're involved with protein. Right? Without this nutrient, you cannot make protein. Remember, protein allows us to grow, right? Like muscle grow, skin grow, traits, physical appearances. And that will be nitrogen. Nitrogen is another element that is part of, very important, essential, and it also involved in a cycle, right? Remember, nitrogen are found in amino acid, are used in amino acid, and remember, amino acid are used to make protein. Protein is for grow, okay? And they also cycle from living to non-living as well, okay? So let's take a look at it. Okay, nitrogen cycle, right? The cool thing about nitrogen cycle is that the air that we breathe in right now, it contains 78% nitrogen, atmospheric nitrogen. Right? We tend to think all the air we breathe in are oxygen, but no, only 21% are 21% are oxygen, and the other 1% are other weird air, like could be methane or, right? But 78% of the air that we're breathing in now are nitrogen. So, and we need nitrogen to make protein, to grow. So technically, why do we need to eat protein, right? Why do we need to make protein? Why do we need to recycle nitrogen if we can just breathe in? While unfortunately, 78% of the air that we breathe are nitrogen. Those nitrogen are not usable in our body. Our body don't recognize them. Our body will kick them out, right? We just breathe in, we exhale out the nitrogen. We can't use them unless we put them through a cycle, a conversion, okay? So it's like this. You have a lot of nitrogen in the air, right? A lot, 78%. 8%. We cannot use any of them. Or animal cannot use it. The only way we can use them is it has to be taken in by these bacteria. We call them nitrogen fixing bacteria. Nitrogen fixing bacteria. They tend to hang out in these legume, like the circular structure underneath the plant. Right here. You can see them in like beans and peanuts. Plant, they have these legume. They live in here. So they live in these roots. So their job is to take in the nitrogen from the air, right? And then they convert this nitrogen into usable nitrogen, and the plant will take it in, right? And then who eat the plant? The animal. And then who eat the animal? Like the rabbit, well, human or other animal. And that's how we transfer the nitrogen. And then when the animal die, these decomposer bacteria, again, you see the importance of decomposer and detritiable. They then recycle this nitrogen and they bring them back into the air again. So that is a simplified version of nitrogen cycle, right? So let's go over them a little bit slower, okay? So again, nitrogen in the air, there's 78% of them, but we cannot use any, or animal cannot use any. We need these nitrogen fixing bacteria in the roots of plants. And their job is taking this nitrogen from the air, and they would then pass it to the plant. The plant would then be eaten by the rabbits. Then we eat the rabbits, and then we and the rabbit die, and the plant die, and then will be recycled back. Okay, so that's a simple version of it. So this brings me to that question. If you're a farmer, what do you have to do every year after you your crops? You collect your crops, right? You have to plow the field, right? You have to plow the field. And why do we have to plow the field, right? Is it so we can put the seeds in and that's it? No, right? When you plow the field, what happens is that you're recycling the soil. Because what happens is the soil, so you have nitrogen in the air. They will be pushed down, like raining or thunderlight, they'll be pushed down into the soil. But they're gonna stay on top of the soil. So they don't get a chance to go down to the roots of the plant. So then we have to plow the field to rotate the soil. So we bring the soil that has the nitrogen nutrients into the ground so the plant can use it. The nitrogen fixing bacteria can use it. The plant can pick it up after, right? And that's why we farmer have to plow their field every season to recycle the nitrogen, okay? Because nitrogen in the air cannot go down underneath unless you recycle it. All right, so that's nitrogen cycle. Living organisms convert nitrogen between various forms. So again, take a look at this nitrogen cycle so you can understand. So within the nitrogen cycle, you have two processes, and that's part of your vocabulary. The first thing is nitrogen fixation. So nitrogen fixation technically means what the word is, fixing, is converting. It takes the nitrogen from the air and push it to the soil, and they fix. So the plant can use it, right? This is what we call nitrogen fixation, right? And then once the plant, the animal die, that nitrogen in their body are then decomposed and then released back into the air. And this is what we call denitrification. De mean remove, right? Root word, demove. So that's when you have another bacteria. The job is to bring back the nitrogen back to the atmosphere, all right? And that summarizes our nitrogen cycle. All right, so, and then the last thing is very simple, the water cycle, right? Water is another nutrient, a biogeochemical cycle that's very necessary, right? We know we need water. Remember, we learned beginning of the year how many percent of body are water? It is around 70%, right? 70%. And you probably learned this already, right? So water go through different process, right? You have water in the lake, and then the sun heat it. It then evaporate, what we call evaporation. Plants also evaporate water, what we call transpiration. So the difference between evaporation and transpiration is that depending on what is in the living thing, transpiration. And then for human, when we evaporate our sweat, our water, perspiration, right? Perspiration. So technically, it's just mean transpiration, just mean evaporation of water in plant. And they get up to the sky, to the atmosphere, is water vapor. It colder up here, cold. When it's cold up here, water will condense, right? The gas molecule will come together, cold come together, condense into cloud. And then when the cloud's so heavy, it starts to rain. And we call that precipitation rain. And you have runoff, and that's it. And that's the water cycle. Not that hard, right? So review the water cycle, right? So why are nutrients important, right? We know that. We know we need them, right? Nutrients are important for the survival of our life. They show up in our reaction, and they are used to make macromolecule, carbohydrate, lipids, protein, and nucleic acid, all the things that we need to survive, to be us. So just to summarize what we just learned so far, ecology is to show how organisms interact with each other, right? You don't just live on this planet by yourself. You have other organisms, and we are cycle stuff. But there's no new water, there's no new carbon, there's no new nitrogen. We have to cycle from different form of life, right? And sphere. All right, so that's it. I will leave the summary to you. So make sure you watch this video so you understand the know better. And we will expect to have a Kahoot next week. All right, so thank you. Watch as many times as you like. All right, bye-bye.